Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shane, coming to you live from Milwaukee Grant Middle School. And in this video, we're going to be walking through the IXL section, W.9, where you're solving some multi-step equations. So I want to make sure that you are, using that Desmos Calculator, which I have displayed on the screen, and that way you can kind of see, where we're at and where we need to be. So I'm going to go through these. Again, you want to make sure that you're using that DCM. Again, as a reminder of what that is, we're saying that we want to distribute. We want to do the distributive property first. Distribute. And then we can combine like terms. Combine like terms. And then we lastly manipulate the variable. And what that means is we're just kind of doing the multiplicative inverse property. So manipulate the variable. So as I go solve this, again, I want to make sure that I can do just that. So if I have this equation, I'm actually going to multiply 2 to both sides. So I have v minus 6 over 2 is equal to 1. So I kind of want to make this a little bit easier for myself, and what I want to do first is I'm going to multiply both sides by 2. The reason why I'm doing this is because on my left side it will cancel it out. So again, I would have that this just is v minus 6 is equal to 2 times 1, which is 2. Then I have a simple one-step equation. Again, I would say that I can add, so I'd add 6 to both sides. Again, if you want to use those railroad tracks, training wheels, whatever you want to call them, that certainly is fine. And so let me back up and say I have v is equal to 8. And so now to check that, again, I type in the left side of my equation. So I'd say I have a fraction, and I'm going to say v minus 6 over 2. And I have to say my right side of the equation, which is just 1. So what I'm trying to do is I'm trying to set these two lines in the calculator equal to each other. Again, the only equal sign I need is when I define my variable, and I'm saying if v equals 8, these two should be equal. And again, we see that because we're saying that, hey, this is equal to 1, which is our right side of the equation. So we know we are good with v equals 8. So same setup, and make sure you hit that clear all button for those equations. So again, DCM, I want to make sure that I am distributing first, combining like terms, and then manipulating a variable. So again, since I can distribute, I want to do that first. I draw my box. Let me do that a little bit better. Draw my box. So I have a positive 2, and then I have, what do I have? I have a positive 1r, and I have a negative 4. Multiply each of the inside terms inside the parentheses by 2. So I'm going to have a positive 2r, and I'm going to have a negative 8. So now my equation is just that. It's going to be 2r minus 8, and I have it is equal to 4. Simple two-step equation. Again, we distribute it first. Now we want to combine like terms. Again, we're trying to get all of those constants on the right side and all the variable terms on the other. So again, I want to show my inverse operations in red, so I'm going to add the opposite to both sides. On the left, I am just left with 2r equals, and I have 12. So we combine like terms. Now we need to manipulate the variable, which again, we just always divide by the coefficient. And so we divide both sides by 2 to get our answer, r equals 6. Again, we can check, as you should. Again, this is the rare case where you get to see, hey, what is my answer for my problem? So I'm saying, is that equal to 4 when r equals 6? And yes, since these two lines are equal to each other, we know we are good. So I'm going to say for this one, r equals 6. All right, so now we're getting some decimals up to the challenge mode. I'm more than ready. Let me take a snip of this. All right. So now, again, anytime I have that denominator like that, I kind of want to get rid of that first. So I'm going to have 5.06, and I have all that over 2, and I'm setting it equal to that decimal. So again, I want to, my first inverse operation, I want to get rid of this 2, and so I have to do the inverse, which is multiply. So I multiply both sides by 2. Again, multiplicative inverse is just 1, and so I have k minus 5.06. 5.06 is equal to, and then I can type, just to be sure, 1.59 times 2 is we have it here, 3.18. Simple one-step equation. Get all the constant terms on the right side. So I add 5.06 to both sides. 5.06. And so I should have k is equal to, well, let's find out. Let's take our answer plus 5.06. So I'd say, I think that k is going to be 8.24. And what you can do is, if you want to save some time, you can actually just type in k is equal to that amount. So I'm defining what k is right there. And then I can type in my equation. So if I'm saying k, all right, let me type in my fraction. I have k minus 5.06 over 2. And it does equal 1.59. So be very mindful of what your answer is. Again, we said our answer is 8.24. 8.24. Excellent. Moving through very smoothly. You want to make sure you can distribute first, combine like terms, and manipulate the variable. So I have 1.21 times each of those inside terms. Actually, yeah, that's fine. Let's see if this works, because I might have a better idea, but we can try this out as well. What I want to do normally is multiply those together. However, what I could do is I could divide. I could actually divide both sides. So on the side here, let me actually try this out. I could divide both sides by 1.121. So if I wanted to, we'll see if I get the same answer. Again, I would divide both sides by 1.21 because it makes it a little bit easier to see. I'd have k minus 2 is equal to 1, which k would be equal to 3. So let's see if I get the same answer. So I have 1.21k, and let's see, I have a negative 2, I have a negative 2 times that 1.21. So I'm going to have a negative 2.42. So I have my new equation after I distributed. And so now I can set up a two-step equation. And so I want to show, again, I want to get all those constant terms on one side. Doesn't matter what they are, I know what to do. So I add 2.42 to both sides. On my left side, I'm just left with 1.21k is equal to, let's see, I have 3.63. And you better believe it, divide both sides by the coefficient for that last step. And so we would say for this one, k is going to be equal to 3 as well. I can still prove it using that Desmos calculator. That way I can show off as well. So I'm saying, is that equal to 1.21 when k equals 3? And you better believe it, it is. So I'd say for this one, k is equal to 3. Moving on, let's actually, let's see, can I bump it up a little bit further? Kind of want to get some variables on both sides without going too far here. So I can have for this one, let me clear this out. So now I want to distribute combine like terms, manipulate the variable. So I'm going to say, all right, I want to have 4.5 times each of my inside terms. And so I have a v, a positive v specifically, and I have a negative 15. So I'm going to do and have 4.5v, and then I need to do 15 times, or excuse me, negative 15, so make sure you have that negative in there, negative 15 times 4.5. So I'd say this is going to be negative 67.5. So now, instead of these parentheses, I now write my equation. So I have 4.5v minus 67.5 plus 1.6 is equal to 19.6. I can combine some like terms. I have a constant and another constant, again on the same side, and so I want to do those first. And so I'd say, all right, I have that answer plus 1.6. And so I'm going to say I have 4.5v, and then I have minus 65.9, and I have still equals 19.6. Simple two-step equation. Add the opposite to both sides. So 65.9, 65.9. On the left it cancels out, and that 4.5v comes down. And my Desmos calculator, I can still use it. I can say I have a 65.9 plus 19.6. So I'd say 85. I can say this is 85.5. Always divide by the coefficient for that last step. And so I'm going to divide both sides by 4.5 to get our answer, which we will soon find out. So v is equal to, let's find out, take that answer, divide by 4.5. So we would say this is 19. All right. Again, to check, I can type it in exactly as it looks. So I'd say 4.5 times v minus 15 plus 1.6. We're seeing, does that equal 19.6 when v equals 19? And yes, it does, and so we know we are correct. So it's saying when v is 19, this is correct. I'll keep powering through, maybe get to 100, that way we are good. Or maybe I'll stop at 80, I'll see where we're at. So we do new. I can multiply both sides by, so I have j minus 2.8 over 4 is equal to 2.4 on the right. Okay, I want to get rid of that 4 in that denominator, so that way it looks a little bit easier. So I'm going to multiply both sides by 4. So I have j minus 2.8 is equal to, let's double check in our Desmos Calculator, 2.4 times 4 would be 9.6. Make sure you can do that one step that's remaining. So I have plus the opposite to both sides. So I have J is equal to, well, let's find out. I'll take an answer, 2.8. Make sure there's a plus sign in the middle. And I can say this is 12.4. Always want to double check my work. And so I'm saying, does 2.4, is that equal to the fraction J minus 2.8 over 4 when J is equal to 12.4? And yes, again, since those two lines are the same value, we know we are good. So I'd say my answer for this one is 12.4. Cruising on through, still keeping my head up, that way I can see what is in the curve. Same setup. I have b minus a negative 4 over negative 3 is equal to negative 4. Multiply both sides by a negative 3. On the left side it cancels out, and so we're just left with b minus a negative 4 is equal to a positive 12. So be very mindful of this. Again, when you have minus a negative, it is the same thing as adding a positive. So I can rewrite that equation. Again, that's a 7th grade idea. However, I want to just subtract 4 to both sides, so that way I can get the variable by itself. And so I'd say b is equal to 8. Always double check. I have the fraction b minus a negative 4. If you need to, you can put those parentheses in it, so that way you're saying, hey, I have a negative 4, I'm subtracting by a negative 4. And then I'm saying, does that equal negative 4 when b is 8? And so yes, since it is the same value, again, these two lines are the same, so we know it is equal to 8. Still same setup. Let's have j minus 7.5 over 2. 3.2. Multiply both sides by 2. Should be pretty simple so far. So I have j minus 7.5 is equal to 6.4. Add the opposite to both sides. And so we have j is equal to, let's say, 13.9. I'm going to actually speed ahead and try and see if this works. I have confidence in myself, and so should you. I have k minus 6 over negative 2 is equal to negative 1. Multiply both sides by the denominator, so I multiply both sides by a negative 2. So I have k minus 6 is equal to positive 2. Add 6 to both sides. And I have k is equal to 8. Alright, so yes, finally have some variables on both sides. This is what I was trying to get to. So now, what happens when there are variables on both sides? Well, you want to look, so variables on both sides. You want to look for lowest coefficient. The lowest coefficient. Let's actually spell that a little bit better and a little less sloppy. There. So there's nothing to distribute, so that one's already done. Combine like terms and manipulate the variable. Always still the same steps. So let's see. I have on the left side, I have 10c plus 9 is equal to 2c minus 7 plus 10c. So now, what I have to do is this. I want to first combine my like terms on the same side. So since these are on the same side, I have a positive 2c and a positive 10c. I can combine those together to get the following. I'd say 12c minus 7. All right, so now I want to look for that lowest coefficient. So which is going to be my lowest coefficient? Again, that's that value attached to my variable. So I'm comparing 10 and 12. Well, we know that 10 is lower, and so that is what I'm going to subtract by. So let me write that. So look for a lowest coefficient and subtract. All right, I may actually say, let me say, and add the inverse, meaning the opposite. So I said that 10 is going to be my lowest, and so I'm going to subtract 10c from both sides. So I subtract 10c from both sides. That's how I know where to start. On the left, I just have the following. So let me write that out. I'd have a 9, because the 10c's cancel out, is equal to 2c minus 7. Two-step equation, add 7 to both sides. Try and get all those constants on one side. So we have 16 is equal to 2c. I have all of the like terms on one side. Divide both sides by c. Divide both sides by 2 to get my answer for c. So I'd say c is going to be equal to 8. To prove that, again, this is where that Desmos calculator really is important. So we're trying to figure out, well, I need to have this left and right side. So I need to say, all right, my left side is 10c plus 9. My right side is 2c minus 7 plus 10c. So you have to be very careful. Again, you want to make sure you type it in exactly as it looks. And you want to make sure that you're saying, okay, I'm trying to get these two expressions. I'm trying to get these two expressions equal to each other so that way they form an equation. So are they equal to each other when c equals 8? Yes, they are. Again, it shows that they are the same value of 89. Again, we're not trying to get these equal to 8. We're trying to say when c equals 8, are these two expressions equivalent? So yes, they are, and so we are good. I'll keep going because I do want to make sure I have some nice challenge ones in here. So now, still the same setup. I want to make sure I do distributive property first, combine my like terms, and then manipulate the variable. So I'm going to do exactly that. I'm going to work here first. So I'm going to do distributive property. So I do, let me actually give myself a little bit more space than that. I'm multiplying, again, make sure you are mindful of that negative sign. So I'm multiplying that negative 9 times a negative 1w and another negative 9. So this would be a positive 9w, and this would be a positive 81. So again, anywhere where it has that, where those parentheses were, I now can write that expression instead. So again, the rest of the equation, however, will stay the same. So my equation is going to be this. It is going to be W plus 9W plus 81 is equal to negative 10 minus 5W plus 1. So I want to make sure now I can work on the same side first. So I'm going to actually combine this 1W and positive 9W and say this is 10W plus 81. And I can also combine these two. I can say I have a negative 10 and a positive 1. When I combine those two together, I'd have a negative 9. So now, what do we want to do? We want to look for the lowest coefficient. So again, so we did the distributive property. Now when we are combining like terms, find lowest coefficient. Meaning I want to see which one is on efficient. It is efficient to be able to spell efficient correctly the first time. I want to see, okay, I have negative 5 or positive 10. Which is lower? Well, we would know that negative 5 is lower, and that is what we're going to add the opposite to both sides. So I'm going to add a positive 5W to both sides. So plus 5W to both sides. On the left side, they cancel out. The negative 9 comes down. The 81 comes down, and then we have 15W. Still combining like terms, I'm going to subtract 81 from both sides. That way I can get a variable by itself. And so I have 15W is equal to, let's say, negative 90. So I combine my like terms, and lastly I want to divide by the coefficient, which is just manipulating the variable, and that should be it. So I'd say W is going to be equal to, let's say 4, 8 maybe. Nope, too far. It'd be 6. Yes, so I'd say this would be equal to negative 6. If I'm unsure, that's okay. I can check my answer using that Desmos calculator. So type it in exactly as it looks. So I'm going to say my left side is W minus 9 times the quantity negative W minus 9 again. So that's the left side. My right side of the equation is negative 10 minus 5W plus 1. We're saying, do those two lines equal each other? Are those two expressions equivalent when W equals negative 6? And lo and behold, I never had any doubts. They are both equal. So I'd say W is going to be equal to negative 6. So again, make sure you are seeing how this works. I know that was a little bit longer of a video, but I did want to do tons of examples for you guys. That way you have it. Make sure to ask questions, use that Desmos calculator, and as always, super slam that subscribe button.